I want to go through a couple of more examples related to cost volume profit analysis. This one example has to do with a concept called operating leverage. Operating leverage measures how sensitive your NOI is to a percentage change in sales, and it's typically a function of your cost structure. So to look at this, I've put up two companies, Company A and Company B. Now, you'll notice a couple of things. Right off the bat, you may notice that both companies are incurring $100,000 in sales, and both companies are generating off of that $10,000 in net operating income. Here's the distinction. Company A is predominantly structured through variable costs, and they have variable costs of $70,000, leaving them with a contribution margin of 30, fixed expenses of 20, and that gets them down to the net operating income of 10,000. Company B, on the other hand, has only $20,000 in variable costs, so they have a much higher contribution margin, but their fixed expenses are $70,000, again, leaving them with a net operating income of $10,000. So the only distinction between the two companies is their cost structure. Now, operating leverage, very simply, is calculated as being the contribution margin at a particular sales level divided by the net operating income. So for Company A, they have contribution margin of 30,000, net operating income of 10,000, so they have an operating leverage of 3. Company B, on the other hand, has contribution margin of 80, again, net operating income of 10, so they have an operating leverage of 8. So what does that mean? Well, let's say that both companies are forecasting an increase in sales volume of 10%. The operating leverage multiplied by the anticipated increase in sales volume will tell you the percentage increase in NOI. So Company A, all things else being equal, sales price, variable cost per unit, fixed expenses, would generate a 30% increase in NOI if they have a sales volume increase of 10%. Whereas Company B can actually look for an increase of 80% in NOI. And if you look at the different companies, it should be clear as to why. Company A is predominantly variable costs. Those costs, by definition, will increase as well when the sales volume increases. In contrast, Company B is predominantly fixed expenses. Assuming, of course, that we're in the same relevant range, those fixed expenses will not change when the sales volume goes up. So all things being equal, a higher concentration in fixed expenses will generate a higher NOI for a particular increase in sales volume. Okay, so that makes sense. Let's all go fixed expenses. But be careful, because that same phenomenon will occur if there is a decline in sales volume. So by the same token, if sales volume decreased by 10%, Company A's NOI will only decrease by 30% because they're predominantly variable costs, and those costs will go down at the same rate as the sales. In contrast, Company B is still going to have to cover that high volume in fixed expenses. So it's a balancing act. What risks are you willing to take, and what structure, how do you want to structure your costs accordingly? Now, let's just, if we go down here, all I did here was I just put some numbers to prove the point. So if sales go up 10%, they're going to be 110,000. Variable costs will go up for company A, leaving them with an NOI of $13,000, an increase of 30%. By the same token, company B, sales go up to 110,000, variable costs increase by only 2,000, and our net operating income goes up the 80%. All right, one last concept discussion, and that is, how does break even get impacted when you have multiple products? We have kept everything pretty simple, pretty straightforward by assuming a company sells only one product. We know that's not true. And so I want to look at an example so that you can see the impact that your sales mix has on your bottom line. So to start with, we've got data here. We have two products, product A and B. Our budgeted sales, let's say, include budget of a total of $1 million in sales. But if you look at it, to arrive at that, we're going to assume $700,000 in sales of product A and $300,000 in sales of product B. Now, if you look at your variable costs, you can see for product A, variable costs are 30% of sales, which means they have a contribution margin ratio of 70%. In contrast, product B has a little higher percentage of variable costs and therefore a little lower contribution margin. So to come up with these numbers, the variable cost for A was the sales times the variable cost ratio, and then the contribution margin is merely the difference between the two, the sales and the variable cost. Same thing for product B, variable costs of $135,000, which is 45% times 300,000, and leaving us with contribution margin of $165,000. Then for the company as a total, we have our $1 million in sales. Our variable costs total $345,000. That's just the combined variable cost for product A and product B. Contribution margin for the company as a whole is the difference between those two. And then we have fixed expenses. Now notice the fixed expenses are being accounted for on a company-wide basis. They're assumed to be related to the overall company, not each individual product. And then that leaves us with net operating income of $56,500. And over on column J, you can see the impact of the blending of the two products. The variable cost in total is a 34.5% ratio, and the contribution margin ratio is 65.5%, which represents the blending of the higher ratio for A and the lower ratio for B. Now, when you're calculating your break-even point for a sales mix like this, you're going to want to use the approach wherein you divide the fixed expenses by the contribution margin ratio. And notice I'm using the blended ratio of 65.5%, and that tells me that break-even point in sales would be $913,740. Now, as we know, that assumes variable cost per unit remain the same, fixed expenses remain the same. It also assumes the sales mix is the same. Right now, we're looking at a sales mix of 70%, 30%. 70% of our sales are product A, 30% are product B. For this break-even point to be valid, whatever we sell has to be broken into that proportion. And I'll show you the impact of that not happening. Let's say total sales remain at $1 million, but instead of being 70-30 or split 50-50. Well, so product A now has sales of $500,000. Notice the variable costs are going to change because the variable cost percentage is 30% of sales. So variable costs will go down and the contribution margin for product A will be $350,000, lower than in our budgeted numbers. For product B, sales are going to be $500,000 as well, and their variable costs will actually go up because they have a higher 45% variable cost ratio, and then their contribution margin is going to be $275,000. Total, notice what's happening. Sales still remain at $1 million. Variable costs, however, have gone up because we have sold more of product B with a higher variable cost rate than product A. And you can see that in your percentages here. Instead of 34.5% variable cost company-wide, it's now 37.5%. And our contribution margin ratio company-wide is now 62.5%. We're assume no changes in fixed expenses. Look what has happened to our NOI. It is now $26,500. It has dropped $30,000 strictly because we changed the sales mix. That's the only thing that's different between our budgeted numbers and these numbers. We're selling less of product A, which contributes a higher percentage of sales to the bottom line, and more of product B, which contributes less. And if we recalculate the break-even point with this revised average contribution margin ratio, notice what's happened. Our break-even point has increased. So if we're going to break even with a 50-50 sales mix, we are going to have to generate more sales in order to break even. So keep that in mind, that when you've got multiple products that have different contribution margins, if they have the same contribution margin, then it's going to be neutral. But if they have different contribution margins, then you've got to consider the sales mix in your break-even analysis.